Today we're going to be talking about our last method for solving systems of equations, and that's going to be solving systems by elimination. So far we've looked at graphing and substitution. Those are two methods. The third method is elimination, and the goal of elimination is to eliminate a variable right away. Okay, so our steps are going to be to make sure that the variables and constants are lined up. We're going to get one variable to have the same coefficient with one positive and one negative. Add both the equations together to eliminate a variable. Solve for the first variable, and just like we did with substitution, we're going to plug that variable back in to one of the original equations to solve for the second variable and write our answer as an ordered pair. So again, remember that ordered pair means that you should be writing them in X, Y form. If it's not X and Y, it's A and B or Q and T or whatever it is, you're going to be solving it or writing them in alphabetical order. Okay? So here's our first example. We have 2x plus 3y equals 11 and negative 2x plus 9y equals 1. And we're going to work on making sure that our x's, our y's, and our constants are lined up with each other. And since we have that, now what we need is to have one of the variables have the same coefficient, one positive and one negative. So if we look at these x's, here we have a positive 2 and a negative 2. Those are the same numbers, just opposite signs, positive 2, negative 2. Since those are ready for us to go, we're going to add the equations together. 2x plus a negative 2x, those variables eliminate. That's why this is called elimination. 3y plus 9y gives us 12y. 11 plus 1 gives us 12. And now we're going to solve for y, which means we're going to divide both sides by 12, and y would equal 1. Now that we have what y equals, again, just like we did in substitution, we're going to plug this back into one of the original equations. So you can either choose the top or the bottom equation. I'm going to choose the top. So we have 2x plus 3. We got y to equal 1 in our work, and that's going to equal 11. Okay? So this means that 2x plus 3 would equal 11. And then we're going to solve our two-step equation by subtracting 3 and dividing by 2 and getting x equals 4. Now, just like we did with substitution, we can take those answers, we can take the original equations, we can plug them into Desmos and see if they work. We can take those answers, we can plug them back into the original equations and see if it works in both of them. So if we were to plug that 1 into the second equation, 9 times 1 would be 9. Subtracting that over would give us negative 8. Negative 8 divided by negative 2 is a positive 4. So it does work there as well. It doesn't matter which one you plug in. And we're going to write our answer x, y, right? So 4, 1 is the solution. And again, if you graphed those, you would find that they would cross at the point 4, 1. Okay, our next example, x minus y equals negative 5, and 3x plus y equals 1. So first we need to make sure the variables and numbers lined up. So our x's are lined up with each other, our y's are lined up with each other, and the constants are lined up with each other. Next thing we're looking for, do the x's have the same number, one positive, one negative? So no, they don't. So let's look at the y's. We have negative y and positive y. Those are the same number, one positive, one negative. So we're ready to add our equations together. When we do so, we get 4x. Our y's, negative y plus y, those eliminate. Again, that's why it's called elimination. And negative 5 plus 1 is a negative 4. Now we're going to solve for x. And that's going to tell us that x equals negative 1. We're not done yet, though, because we had two variables. Our answer needs to be written in a coordinate pair, an ordered pair. So that means that we have to find what y is. So we're going to take this and plug it into one of the original equations. You can pick which one you want to plug into. This time I'm going to choose to plug it into the bottom one. The bottom equation does have all positives there, but it doesn't matter which one you pick. So we have 3. Instead of putting x, we're going to fill in that -1 that we just found. Plus y equals 1. And 3 times -1 is -3. And then we're going to add 3 to both sides. And y would equal 4. So now that we have both x and y, we're going to write them as an ordered pair. X, comma y, so -1, 4. And that's our answer for this question. Again, you can double check that by plugging these numbers in to both the original equations or by graphing them in Desmos. All right, next one, 6x minus 3y equals 3 and 6x minus 5y equals -3. All right, so in this process, variables are lined up, numbers are lined up, we're good to go. We're looking, does one of the variables have the same coefficient, one positive, one negative? So if I look at the x's, those are both a positive 6. They are the same number, but they're not opposites of each other. So how are we going to make them be opposites? Well, what we're going to do is multiply one of the equations by a -1. Now, it doesn't matter which one you choose to multiply by the -1, so I'm going to multiply the top equation by a -1. And when we do this, that -1 is going to distribute to everything inside. Every single piece. You can't leave any of them out. -1 times 6x is -6x. -1 times -3y is a positive 3y. -1 times 3 is a -3. The second equation we're not doing anything to, so we're just going to copy that down exactly as it looks. Now we have the same coefficient, one positive and one negative, so we're ready to add our equations together. When we do that, the x's eliminate. Combining those or adding those, 3y and -5y, we get -2y. -3 minus 3 is a -6. To get y by itself, we divide by -2, and that tells us that y is a positive 3. Now that we have what y is, we're going to go back in and figure out what x is by plugging into one of the original equations. And it doesn't matter which one you do, it should just be one of the originals. So I'm going to go back to the first equation and plug in there. So I have 6x minus 3. Instead of having y, I'm going to plug in the 3 that I just got. So we have 6x minus 9 equals 3. We're going to add 9 to both sides and divide by 6. And that's going to give us that x equals 2. Now that we have both x and y, they go in x, comma y form. So 2, 3 would be our answer. Don't get confused and write 3, 2 because that's the order we solved them in. You need to write them in the order, alphabetical order. All right, let's try one more. So we have 2x minus 4y equals 8 and 3x minus 4y equals 10. And so we're looking first, is everything lined up? We're good there. Do we have the same coefficient, one positive, one negative, with a variable? So our x's don't even have the same number. So we're going to look at our y's. We have -4y and -4y. Are those opposites of each other? So no, they're the same number. So that means that we need to multiply one equation by a -1 to make them be the same. So this time I'm going to choose to multiply the bottom equation. It really does not matter either way. So the top equation is staying the same. We're not doing anything to that. When we distribute this -1 in, we're going to get -3x plus 4y equals -10. Now they're the same number, one positive, one negative with the y's, so we're going to be able to eliminate a variable. Make sure that they actually are opposites of each other to eliminate. So this is going to give me negative x, our x's eliminate, equals negative 2. To get x by itself, we're going to divide by negative 1, and x equals 2. Now that we have that, we're going to go back into one of the original equations. So I'll plug into that second equation. So we have 3 times 2, because that's what we got x to equal, minus 4y equals 10. That means 6 minus 4y equals 10. So we'll subtract 6. Negative 4y equals 4. Dividing both sides by negative 4, we get y equals a negative 1. And the last step to write our answer, 2, negative 1. And then you would make sure to check your answer either algebraically by plugging it in or graphically by plugging it into Desmos. That's it.